Hello everyone, this is N. Ramya from Civil Engineering Department. Here I'm going to tell about quality and water testing, environmental. So here is the course objective: the availability of safe, wholesome, and easily accessible water in sufficient quantity, facilitating consumer needs is the course objective. And here is the course outcome. Explain the fundamental principles of water supply, quality, uh, dem- demand of water, and their significance for effective water management systems. So this is a course outcome. And here, first of all, what is a water quality? The water quality is the ability of water bodies to support all appropriate beneficial uses. So here, this quality refers to the condition of water and its suitability for various purposes like human consumption and for aquatic ecosystems. So here are some examples. If water supports a beneficial use, water quality is good. If it is not for beneficial use, then water quality is bad. If water does not support a beneficial use, then it is said to be a poor or improper quality. So here, the water quality here, water can be divided into a groundwater and surface water based on the sources. As we have discussed earlier, right? Source of water, right? Source of water is a groundwater, surface water, and so on, right? So here, the water can be exposed to contamination risks from agricultural industries and domestic activities, like which in agricultural there is a if there is a more use of pesticides or fertilizers, and thus that also leads to the contamination, right? Yeah, industries which is having high chemical which are exposing or to a groundwater or to a surface water, and this water is directly disposing to the source of water like lakes, etc., right? Yeah, domestic activities also. So these may include pollutants such as heavy materials, oils, pesticides, fertilizers, chemicals, and etc. So these heavy metals, oils, pesticides, fertilizers, and chemicals, these are leading to a water quality, like contamination. In contamination, it is making the water quality is a poor quality. Water quality is becoming a poor. It is not good for beneficial uses. So here, classification of water. So water is classified into four types here. Water is classified into four types. One is potable water and palatable water, contaminated water, and infected water. These are four types. Depending upon the quality, they have classified into four types. So first one is for potable water. Potable water is a drinking water which is safe for drinking and pleasant taste, which is used for domestic purposes. Right? These potable water is safe for drinking and it is having a pleasant taste, which used for domestic purposes, and it is overall it is safe to use for any purposes. So now coming to palatable water, it is pleasing. It has presence of chemicals that do not cause a threat to human health. Contaminated water, water containing unwanted physical, chemical, and biological substances, which is unfit for drinking and for domestic purposes. Contaminated water is unfit for drinking and also for using a domestic purposes, because it is containing a physical and chemical and also biological substances in the water, so which is making a water quality a poor. So it infected water, water contaminated with pathogenic organisms, which is the water containing a pathogen, pathogenic organism, then that water we are calling as a infected water, which is not suitable for any purposes also. So as here, potable water is used for drinking purpose and for domestic uses, and palatable water is that is not harm to the human body, but it is not suitable for drinking. Just we can use for other purposes like washing and for domestic purposes, let us say. So contaminated water is having a physical and chemical biological substance, and that which is unfit for drinking and also for the domestic purposes. Infected water is it containing some organisms, bacteria, virus, etc. So these water which is unfit for drinking, and that water we are calling as a infected water. The parameters of water quality. So there are three parameters. One is physical parameter, chemical parameter, and biological parameter. There are three types of water quality parameters are there. One is physical, chemical, and biological. What are these parameters we see in detailing? So first here in physical parameter, physical means that physical comes under color, seeing, taste and odor, solids, temperature, turbidity, and electrical conductivity. These are all comes under the physical parameters. So here, physical, when we see a water, by seeing also we can say that the water is clean or it contains any uh, impure impurities, right? So by seeing also we can say that if the water is clear, then we say as water is suitable for. So taste and order by tasting and solids, temperature, turbidity, and electrical conductivity. So your first one is color. So water color indicates the presence of dissolved and suspended substances, both natural and man-made. So the impact of these natural colors from organic matter like brownish from leaves are common, and abnormal color like red, blue, yellow signals possible contamination from industrial effluents or chemical spills. Causes: organic decays, minerals like iron, magnesium, and pollution from chemicals and dyes. Measurement assessed visually are with the colorimeters in true color limits. That is, if seen with TCU. Units of the color to identify the color in the water quality is TCU, true color units. Now coming to a taste and odor. The taste and odor of water reflects the presence of dissolved gases, minerals or organic and chemical pollutants. The taste and odor water reflects the presence of dissolved gases, minerals, organic and chemical pollutants. It is impacting the unpleasant taste or odor can make water unsuitable for drinking. If it is unpleasant in taste and if it odor is bad, then it is not suitable for drinking. Odor such as fishy, misty, or chemical smell indicates the possible contaminations. Causes are natural sources like algae and decaying vegetation, and pollutants from industrial sewage and chemical spills. Due to this, they will see a order, different orders, and also taste. So the measurement of these taste and odor is sensory evaluation, gas chromatography for detailed analysis. Solids. So solids in water includes suspendable solids like visual particles and dissolved solids like minerals and salts. So types are total dissolved solids, measured salts, minerals, and ions dissolved in the water. So total suspended solids is measures as particles suspended in the water. Impacts are high total dissolved solids can affect water taste and causes scaling in the pipe. High solids is causing the scaling in the pipes, and also it affects the water taste. And a high total solid suspension can reduce water clarity and affects aquatic life and clog filtration systems. Causes is due to the soil erosion, runoff, sewage discharge, and industrial processes. Measurements are: TDS is measured in milligram milligrams per liter using conductivity meters, while TSS is measured through filtration and drying methods. Temperature. Water temperature indicates the heat content of water influencing chemical reactions and biological processes. Impact affects dissolved oxygen levels. Warmer water holds less oxygen, influences the metabolism and production of aquatic organisms. Causes are seasonal changes. Due to the seasonal change, water depth and industrial discharges, and also the weather condition. Measurements are: it is measured using the thermometer or digital temperature sensors in degrees Celsius or Fahrenheit. The measurement of the temperature is Celsius or Fahrenheit. It is measured with the thermometer or digital temperature sensor. So here main turbidity. Turbidity is very important in water quality. The turbidity plays very important role. The turbidity is a measure of water clarity. It measures the water clarity. So here the turbidity measures the degree to which water loses lo- its transparency due to the suspended solid. Due to the suspended solids, its transparency it will loses. The turbidity measures the cloudiness or haziness of water caused by suspended particles. As we see in the image here, the turbidity, if the solid suspension is high, then the water is not clear, and this it has very suspended particles, as we see in this image, right? So coming to a low turbidity, that means which is clearly, it is transparency. We can see the water very clear, right? Here the see, it is low, it is having very low turbidity, and has going up. Here it is somewhat high, it is more than this, and it is also completely more than all of this, right? Which is having high suspended particles in the water. So now turbidity can caused by many things. How turbidity is causing? By because of the clay, silt, algae, plankton, sewage, dissolved colored organic compounds, and tiny inorganic and organic matter. These are all causing the suspended solids in the water. Turbidity. So high turbidity reduces light penetration. If it is having high turbidity, means high solids particles in the water, which is not allowing to penetrate a light into this. So which affects photosynthesis in aquatic plants and disrupts the aquatic ecosystem. Causes soil erosion, waste discharge, algal blooms, and stormwater runoff. These are all the causes, and the measurement are measured in nephelometric turbidity unit, that is NTU, using as a turbidity meter. The turbidity measurement method. So the nephelometric method is the most common method used for measuring the turbidity. So here the main principle is it measures the intensity of light scattering at a 90 degrees angle from a light source that passes through the water sample. So here the equipment, turbidity meter procedure is: a water sample is placed water sample is placed in a clear cuvette. The device emits a beam of light through the sample. Suspended particle scatters the light and sensor measures the scattered light. So the higher the scattered light, the greater the turbidity. So they are allowing a light to pass through the water sample. If it is having the higher scatter in light, then the turbidity is more. If it is having less, the turbidity is less. Here, this another method, the switch disc method, that measures the water transparency using a circular black and white painted disc. Here, what they are doing here, the disc is lowered into the water until it is no longer visible. The depth at which the disappeared is recorded. The greater the depth, the clearer the water, then it is low turbidity. Commonly used in lakes, rivers, and oceans for quick manual turbidity assessment. It is used in a lakes or reservoirs. The now treatment of methods. So coagulation and flocculation. So the coagulation is what chemicals like alarm are added to water to neutralize the charge of suspended particles. Alarm is added to the water to neutralize the charge of suspended particles. Here in the flocculation, the neutralized particles clump together. The flocculation is what? The neutralized particles, which is done by a coagulation, the neutralized particle clump together into a larger, heavier aggregates called flocks, making them easier to remove. First, they are adding a chemical like alarm to the water, and after that, they are making a neutralize the charge of suspended particles. After that, these neutralized particles clump together to form a larger, heavier aggregates called flocks, which is making easier to remove the suspended particles. Now, second one is sedimentation. Water is left undisturbed to allow flocks to settle at the bottom. Whenever if the water is having heavier material, so that heavier metal, if you are not disturbing these water, then what happens? The solids will settle at the bottom of the beak, right? The solid particle will settle at the bottom if it is not disturbed or undisturbed. So that is what a sedimentation. This process is commonly used in large scale water treatment plants. Treatment method, now it is filtration. Third method is water passes through filters made of sand, gravel, and membranes. This step removes smaller suspended particles that didn't settle during the sedimentation. If water is not settling, particles are not settling in the sedimentation process, then that particle can be removed by filtration. That is filters made up of sand, gravels, and membrane sheets. That small suspended particles can also be removed by using the filtration. Now, disinfection. After reducing turbidity, water is disinfected using the chlorine or ozone or UV lights. These kills remaining microorganisms. Now here is electrical conductivity, that is denoted by EC here. The EC measures the ability of water to conduct electricity, which depends on the concentration of dissolved solids in ions like sodium, calcium, and chloride. This impact high electrical conductivity indicates high salinity, affecting water usability for drinking, irrigation, and for industrial purposes. So low electrical conductivity may indicate pure water, but could also mean nutrient deficiency for plants in agricultural setting, and which is caused by natural mineral dissolution, industrial waste discharges, agricultural runoff, and seawater intrusion. Measurement measured by using a conductivity meter, and is microsiemens per centimeter. Units are millisiemens per meter. That is denoted by ms by m. Here another one is micro siemens per centimeter, 2 meters, and also in centimeters. Now chemical parameters of water quality. So here chemical parameters of water quality are, first one is pH value. The main parameter, the important parameter is pH value. If pH value is more than the basic, the drinking pH value is a 7. If it is greater than, also not good. If it is less than, also it is not good. So depending upon these pH, uh, hardness, iron, manganese, copper and zinc, chloride, chlorine residuals, nitrogen, and fluoride. These are all chemical parameters. Now let us see a pH. So pH measures a water acidity, if it is water is acidity or alkalinity. So here the scale of these pH is 0 to 14, right? 7 is a range. It is for safe for drinking purposes. And hardness, so determines the calcium, what minerals are there, what salts, calcium, magnesium, magnesium content, indicating water suitability for domestic and industrial users. Alkalinity, water capacity to neutralize acids. Alkalinity is done to neutralize the acid water. So dissolved oxygen indicates water ability to support aquatic life. So dissolved oxygen, which is supporting the aquatic life like fishes and etc. Water living organisms. Biochemical oxygen demand. These measures oxygen consumed by microorganisms while decomposing organic matter. Biochemical, here is the chemical oxygen demand. COD measures the total oxygen required to break down organic and inorganic matter. Here, to break down the organic and inorganic matter, chlorides high level can indicate pollution. Nitrates and phosphates excess amounts can cause eutrophication, leading to algal blooms. Heavy metals, lead, mercury, and arsenic, toxic even in trace amounts. Pesticides and herbicides, harmful chemicals for agricultural runoff. Here, let us see a pH. A pH, as we said, the pH is defined as a negative algorithm of the hydrogen ion concentration, and it is a dimensionless number indicating the strength of acidic or a basic solution, alkaline solution. Actually, the pH of water is measures of how acidic or how alkaline a water. If acidic contains extra hydrogen ions, H plus, and basic water contains extra hydroxyl, that is OH ions. pH ranges from 0 to 14, as we said, 7 being neutral. The pH which is having less than 7, we call it as acidic water, and if it is having pH greater than 7, we call it as a base or alkaline water solution, right? Water is neutral with a pH close to 0 and the temperature at 25 degrees or 26 degrees centigrade. Copper and zinc, other chemical parameter. So copper and zinc are non-toxic if found in small concentration. If it is it in some small concentration, then it is non-toxic. Actually, they are both essentials and beneficial for human health and also for plant and animals growth. So these can cause undesirable taste in drinking. This only cause the undesirable taste in drinking. At high concentration, zinc imparts a milky appearances to the water. They are measured by the same method used for iron and magnesium measurements. Now here iron and magnesium. Here, although iron and magnesium do not cause health problems, if they impact noticeable bitter taste to drinking water, even if it is very having a low concentration. These metals usually occur in groundwater in solution like ferrous and manganese. When these ions are exposed to air, they form the insoluble ferric and manganic forms, making water turbid and unacceptable to most people. These ions also cause a black or brown stains on laundries and plumbing fixtures. Here, the biological parameters of water quality are bacteria, algae, viruses, and protozoa indicator organisms. First, we see a bacteria. So, bacteria are a single-celled plant that can ingest food and reproduce at rapid rates if water's pH, food supply, and temperature are ideal. Bacteria can grow rapidly. It is almost impossible to count the number of bacteria in a water sample. In most of cases, bacteria will reproduce at a slow rate in colder water. If it is cold, the bacteria reproduction is slow. There are many harmful waterborne diseases which is caused by high amount of bacteria in the water. Like the diseases are cholera, typhoid, and etc. These are caused by a bacteria in the water. Waterborne diseases are like uh, cholera, typhoid, and etc. So here the bacteria are coliform bacteria test detects the fecal concentration, and E. coli is a common indicator. The microbial count, the total count of microorganisms in the water. The pathogenic detection test for harmful pathogenic like Giardia and Cryptosporidium. Water sampling method is a grab sample, composite sample, or automatic sampling and depth sampling. So your single sample collected at a specified time or place is called a grab sample. Composite is multiple samples taken over a time combined for analysis. Multiple times taken over a time for like taking some the period uh, after 1 hour. Multiple samples taken over a time. Yeah, automated systems collecting samples at regular intervals. Depth sampling and sampling collected from various depths in the water bodies. These are the four water sampling for testing the water quality. We have water testing methods and instruments are on-site testing or portable kit for basic parameter like pH, turbidity, and chlorine. On-site testing, portable means drinking water. It is also used for domestic purposes, and that is testing is like pH and turbidity and chlorine portable kit by using portable kit. And other one is laboratory testing for chemical analysis of metals and nutrients. They use the spectrophotometric. And here chromatography detects the pesticides, herbicides, and volatile organic compounds. And titration measures the hardness and alkalinity and chlorides. And membrane filtration identifies the microbial contaminations. And last one is atomic absorption spectroscopy detects the trace metals, trace the metals. And here water quality standards and guidelines are from the water health world health organization, global standards for drinking safety water. An environmental protection agency enforces water quality standards for different uses, and Bureau of Indian Standards BIS specifies the drinking water standards in India. These are the standards for the water quality, and here is the desired limit, requirement of desirable limit, and it is permissible limit. Standards substances like color, odor, taste, turbidity, pH, hardness, iron, chlorides, residuals, like chlorine and fluorides. These are all. These are desirable limits are 5 and so on. Permissibly 20 till 25 we can use. Permissible limits are these. The water quality and testing. Water quality testing involves analyzing the chemical, physical, biological characteristics of water to determine how healthy it is for various purposes. The water quality testing can help identify the presence of harmful chemicals or germs and can also indicate if the water is suitable for drinking, swimming, or supporting an ecosystem. It's determined by several factors like chemical properties, physical properties, and biological properties. Already we discussed chemical like heavy metals and organic and inorganic substances, heavy metals, pesticide, nutrients, and the physical properties like temperature, turbidity, conductivity, and dissolved oxygen levels, and bacteria. And biological is harmful microorganisms like bacteria, algae, etc. So here are some water quality tests as we discussed here. pH, it is to identify whether the water is suitable for drink, like which it is in acidic or in alkaline. Uh, the measures the concentration of hydrogen ion, and it will tells us how water is acidic or alkaline. If it is too acidic, can be unhealthy to drink. And bacteriological tests which check the presence of bacteria such as coliform, fecal coliform, and these tests can indicate that water is contaminated with disease causing bacteria. This test can say that how much amount of bacteria is present in the water and how much amounts of bacterial organisms are present. So, a mineral test determines the mineral content of the water, such as calcium, magnesium, manganese, iron, copper, zinc, etc. High levels of minerals can make water hard and can cause stains or bad odor. Organic and chemical tests look for contaminants such as pesticides, industrial chemicals, petroleum. Physical tests like color, turbidity, or total dissolved solids, suspended solids, color, taste, dissolved solids. Physical test and the importance of water quality testing. Public health protection prevent waterborne diseases. Environmental conservation maintains ecological balance. Industrial use ensures the proper water treatment for industrial processes. Agriculture prevents soil degradation and crop damage. Compliance and regulations meets legal and environmental guidelines. Here are the references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.